Alright, hello. Alright, so this one is state the interval for which, or interval or intervals, the interval for which the function is continuous, and on what interval or intervals is the function continuous. Simplify your answer, type the answer in interval notation, use a comma to separate answers as needed. Okay, so interval notation, I had to look there, I forgot what I meant. It's going to be, something like this or something like that. You're going to comma, separate the answers. And these are, well, you could say they're points. But in here, this, of course, x value. And, no. Oh, that's right, no. I am getting confused. I'm thinking of, coordinates. No, okay, so this is what we're gonna do to see, say if it's like negative infinity to infinity, like that. And if it has the parentheses around it, that means you're including these or you're not including these numbers, excuse me. And you can't include infinity or negative infinity because they're not actual numbers. And if you use the brackets, then you are including the numbers that you're talking about. And we'll see in a minute what I mean. Oops. Let's see. Let's see. Alright, so for the intervals, alright, so basically it's whenever x is equal to, or excuse me, the denominator is equal to 0. So if we have x squared minus 36, and we want to find out when is this equal to, when is it equal to 0. And that's where it won't be continuous. Remember, we found that in the videos before. That's when we have the asymptote, or that's where, if there's not an asymptote, I guess we didn't get into that yet, but the function is just not valued there, or it can't be given these restrictions on the denominator, the laws, or whatever. And so on that last one we just did put a point there, which is the same thing. I mean, alright, so let's see. X squared, we could factor this out, or we could just say, okay, 6 and negative 6, we know those, but maybe there's something, if depending on how new you are at this, you might say, oh, maybe there's more, but let's just factor it out anyway. So that's what, x minus 6, and this isn't the same thing as including your, the brackets. This is just factoring. These just mean, let's do this first before multiplying. X plus 6. So that would give us, if we FOILed this, we'd get this. Well, not the 0, but that's just to prove a point. Alright, so when x is positive 6, this thing right here equals 0, right? Because then 0 times whatever, if this was, or in this case 12, is still 0. And then when x is negative 6, this becomes 0. So we know these two are points in the graph that our function does not exist. Alright, so on our intervals we're going to write it like, let's see, well, we're going to go to negative infinity, which is just natural. We always go to negative infinity first from the left side, unless it's, well, you always do, especially in this case or whatever. So negative infinity to our next leftmost point, negative 6. And we're not including negative 6, right? So we wouldn't draw the bracket, will we? Because we can't include it. If we include it, it's 0 and it's undefined there. So it's negative 6 like that. That's supposed to be a 6, not a b. And then we go from negative 6, oops, not including it again, to 6. And then last, we go from 6. This is just like saying all values of x. When you go to negative infinity to positive infinity, and again, I forgot the parentheses, to infinity. That's it. Very ugly drawing, but negative infinity to negative 6, just checking it. Negative 6 to 6, none of these are included. And 6 to infinity. Yep, that's it. So on what interval is the function continuous? Well, our interval, these intervals. Simplify your answer, write your answer interval notation, use a comma to separate answers as needed. And that's it.